Right. Well, we are going to look at the Fourier sine and the Fourier cosine. But before we do that, let us look at the proof on how do we generate those formulas that we're going to use. Now, the idea comes from this thing of even odd. Now, if G too small, if G of t is equals to G of negative t, then we say this function is even, right? In this case, when we integrate G of t from negative infinite, not from negative a to a dt, it is the same thing as we are saying 2 times an integral from 0 to a g of t dt. It's the same thing again as you integrate from negative a to 0 g of t dt. Now, remember, the function is even because it is reflectable by the y-axis, right? So we get this idea, right? Let me just change color. You get this idea, right? You'll get this idea, right? Right, after this idea, come up with the second one that states that if G of t, not G of t, if negative G of t, if G of negative t is negative G of t, then we say this function is odd. It is odd. In that case, an integral from negative infinite to from negative a to a g of t dt is equals to 0. Is equals to 0 because an odd function, it is reflectable by the origin. Now, I think you will understand this better. So the most important thing here, it is this part. Now, we know that f of t is equals to cos at. Cos at is even, and g of t is equals to sine of at. It is odd. You're supposed to know that. You're supposed to know. I'm just writing it down for you. You're supposed to know that. In that case, for g of t to be even, then the following will occur. If you integrate from negative infinite to infinite, we consider g of t to be even. G of t cos of at dt, what you'll get here, I'm going to get an integral 2 times an integral from 0 to infinite of g of t cos at dt. The reason is being because g of t is even and cos is even. Here we have an even product. So when you have an even product, you're integrating an even function, by the way, so you'll get 2 times that integral, right? Second one, from negative infinite to positive infinite, we have g of t sine at dt, you'll get a 0. Why? G of t is even, sine is odd. So what you'll get here, we're going to get an odd product. We're going to get what? An odd product. So I think that is clear. That one there, it is clear, right? So for g of t to be odd, then the following will occur. So if we integrate from negative infinite to infinite, g of t cos at dt, we are going to get 0. Why? Because g of t now is odd, cos is even. So here we have an odd product. Right? In that case, we look at another principle. From negative infinite to infinite, g of t sine at dt is equals to 2 times an integral from 0 to positive infinite, g of t sine at dt. In this case, we have odd times odd. So if you do that, you're going to get a what? An even product. What you're going to result? We're going to result an even function. So odd times odd function will result to an even function. Right, I know that. Now you understand that. And then you need to recall that e to the power negative j a omega t, it is equals to cos omega t minus j plus minus j sine omega t. You need to recall that. What is the formula for the Fourier transform? This is the formula for the Fourier transform, right? So because that is the formula for the Fourier transform, we know that the Fourier transform of f of t, it is an integral from negative infinite to positive infinite of f of t e to the power negative j omega t dt, right? So we need to expand that. If we do expand that, we are going to have an integral from negative infinite to positive infinite of f of t in bracket cos omega t minus j sine omega t dt. So by closing up the integral, I'm going to split the integral into 2. So I'm going to have an integral from negative infinite to infinite f of t cos omega t dt minus j integral from negative infinite to infinite of f of t sine omega t dt. Now the first condition will play its role. The first condition will be if f of t is even, what is going to happen? When f of t it is even, it turns out I'm going to have even times odd, which is going to give rise to odd, so that will become 0, right? So I'm going to have 2 times an integral from 0 to infinite of f of t cos omega t dt, like that. And then if we say if f of t is even, not even anymore, is odd, then we'll have negative j2 integral from 0 to infinite of f of t sine omega t dt, right? Now, because we have a 2 times an integral from 0 to infinite f of t cos omega t, this is called Fourier cosine. Because we have a negative j2 integral from 0 to infinite f of t sine omega t, this is called Fourier sine. So you will be asked in the major test or anywhere or an exam to calculate the Fourier series of Fourier cosine or Fourier sine. But if they are specific, find the even Fourier transform, they mean the Fourier cosine. If they say find the odd Fourier transform, they mean the Fourier sine, right? But what we are going to do here, it is very, very nice. We are going to do both. In a question, we're just going to do both, right? The question will be find the Fourier sine and cosine. So to do that, of the following. So how can you do it? So we are going to do it in this, using these two formulas. Using these two formulas, yeah. So right, just look at the first one. We have f of t is equals to 2 between 0 less than t less than 2 comma f of t plus 2 is equals to f of t. So we need to find both the Fourier sine and the Fourier cosine. So how are we going to do that? Very easy. Let's look at the sine one first. And then this side we're going to look at the Fourier cosine. The Fourier cosine. So how can you do it? The Fourier sine will use that formula. So Fourier transform of f of t is equal to negative j 2 integral from 0 to infinite of f of t sine omega t. Right, so now it's negative 2j integral between 0 and 2, because we need to integrate this function to these bounds. So it's a function of 2 times sine omega dt, sine omega t dt. So if you take out, I'm going to have negative j4. What is an integral of sine? It's going to be negative 1 over omega cos omega t between 0 and 2. The negative will cancel, so I'm going to have j4 over omega cos 2 omega minus 1. So your final answer should be j4 cos 2 omega minus 1 divided by omega. So this is your final answer if you use the Fourier cosine. Now if you use your Fourier sine, if you use your Fourier cosine, sorry, this was Fourier sine. If you use the Fourier cosine, that is the formula to use. So it's going to be the Fourier transform of f of t is equals to 2 times an integral from 0 to infinite of f of t cos omega t dt, like that. So it's going to be 2 times an integral from 0 to 2 of 2 times cos omega t dt. Take out the 2, I'm going to have a 4, and an integral of cos omega is 1 over omega sine omega t between 0 and 2. Substituting the values there, I'm going to get sine 2 omega minus 0, because sine 0 is 0. So our final answer, it is 4 sine 2 omega over omega. So that is the Fourier cosine of that 2, right? So that is the first answer that we get. The second one, function, it's going to be f of t is equals to t between 0 less than t less than pi, comma, f of t plus pi is equals to f of t. Right. So how can we find the Fourier sine and cosine here? So the best way that you can do it, you cannot just separate it because we need to use some integration by parts. So what I'm going to do, let's find first the Fourier sine. If we do the Fourier sine, the formula states that the Fourier series of f of t is equal to negative j2 integral from 0 to infinite of f of t sine omega t dt, right? So now we have negative j2 integral between 0 and pi of t sine omega t dt. We shall integrate this. So integrating this will be quite tricky, so let us use the integration table, because you need to use integration by parts. It's t, and then you got your integrating with sine omega t. We have been doing this since the Laplace transform, so sorry, I know it kinda hurts now, but this is the end of maths. Plus 0 negative 1 over omega square sine omega t. Next thing we do, take that, multiply it to that. So if you do it, negative j2 in bracket negative t over omega cos omega t, and then plus 1 over omega squared sine omega t between 0 and pi. Right, so if you substitute pi, negative j2, we are going to have negative pi over omega cos pi omega plus 1 over 2 omega square sine pi omega. And then if you substitute 0, we get 0 minus 0. So substituting 0 to cos is 1, but there is a t outside, so that's why it's 0. So our final answer it is J2 in bracket pi omega cos pi omega plus sine pi omega divided by omega squared. So this is your final answer for the Fourier sine. And then to get the Fourier cosine, we need to use that formula. What is the formula? The Fourier transform of f of t, it is 2 times an integral from 0 to infinity of f of t cos omega t dt, right? So it is 2 times an integral from 0 to pi of t cos omega t dt. So again, to integrate this, we need to use integration by part table. So it's going to be s di plus, and then your d, it is going to be t, your I, it's going to be cos omega t, minus 1 over omega sine omega t plus 0 negative 1 over omega squared cos omega t. Right. So next thing that you do, take that, multiply it to that, take that, multiply it to that. So now we have 2 times in bracket t over omega sine omega t plus 1 over omega squared. Sorry, I have spotted a mistake here. I'm spotting a mistake. It's supposed to be minus. Why it's minus? Because you're going to distribute this negative inside. So plus cos omega t between 0 and pi. If we do the calculations, 2 in bracket, if we substitute pi, we're going to have pi over omega sine omega t plus sine pi omega plus 1 over omega squared cos pi omega. And then if you substitute a 1 there, this part, if you substitute a 0, this part is totally 0. This part is 0, but this part is 1, so I'm going to have minus 1 over omega squared. And if you look carefully, your final answer should be pi omega sine pi omega plus cos pi omega minus 1. All of this must be divided by omega squared. So this is your final answer when we take the Fourier cosine and sine series. If you have any questions regarding this, you can leave a comment. So by the way, this is your Fourier sine and cosine series. So this is a simple proof regarding it. So thank you.